Hello, everyone. Welcome to YouTube Live for a very, very important topic, statistics and epidemiology. As the July exam is approaching, so everybody is geared up for the studies. And I think statistics is one of the subject which really gives you the chills that it's a difficult subject, but actually it's not so. So we will be talking about the statistics with the storytelling. How does this idea sounds to you? I think probably that should be interesting. So we'll start with this session with this very important topic. Whether you are a July candidate or a January candidate, this session would be certainly beneficial for you, and we will be talking about almost 10 questions, but very important questions which often appear in the exams. And definitely would talk about certain concepts also, because statistics is not something which, like, I just tell you that this is the correct answer and that's it. You should be able to know that why this is so, what is the concept behind it, so that you can have a similar question in the exam and you can answer it. Now, the most important part about the statistics is that although it appears very scary, but once you are well versed with it, then it is the subject which helps you score very well, because you will have around 15 to 20 questions of statistics in the exam. So once you have done it, it's maths, right? If it's right, it's right. So you get all your marks and you can score very well in your exams. And it is not at all advisable to leave this subject or any subject before you go to the exam. You pay such a hefty fees for the examination, so why not prepare well and go with a full preparation for the exam? So here we go with this session. I would just like to know how many of you find the statistics difficult. Would you please write in the chat box how many of you find the statistics difficult? Or how do you see the statistics as when you hear the word statistics? Oh my God, statistics is coming in MRCOG part 1 or part 2 exam. What do you think about it? Certainly, we're waiting for your answers. Yeah, I know there's certainly a small lag in the YouTube live, so difficult. Oh, difficult. Yes. Yes. So after this today's session, you can let me know the concepts which we have talked today. Yes, part two students can also listen to that, because the definitions, the concepts are going to be the same. Yes, it is good for part two students as well. So let's start. Let's start with the questions, and certainly I'll be looking for who is going to be the hero of statistics. I'm going to answer the questions correctly. So let's start. Here we go. So this is a simple question. First, we start with a very direct question. So all the definitions, neonatal death rate, perinatal mortality rate, maternal mortality rate, maternal morbidity, these all definitions are very, very important for part one exam. So this is with one of the simple questions I'm starting this session. Which of following is the definition of neonatal death rate? So is it 0 to 10 days per 1000 live births, or it is number of deaths in 0 to 20 days per 1000 live births, or 0 to 27 days per 1000 live births, 0 to 27 per 500 live births, or it is per 10,000 live births? Yes, waiting for the answers. Who is going to answer first? Yes, your name will be announced here in the YouTube. Just waiting for the correct answer. Okay, okay, okay. Any more answers? Yes, I can see one of the answers as E. Still looking for more answers. C, C. Yes, C is the correct answer. Very good. Dr. Jayadishi Singh. She is the winner. Good. Congratulations. So you won the first question of statistics. See, it's easy. So we calculate it as number of deaths at 0 to 27 days per 1000 live births. That's correct. And I'm proud of my students. Well taken up and well understood. No, it's not E. What is the difference between E and C? Why you are confusing between the E and C? See, 0 to 27 days is fine. First 28 days is for the neonatal deaths, right? So 0 to 27 is fine. But after that, it is per 1,000 live births and not per 10,000 live births. So this is the very important point which we need to remember in this. So therefore, C is the correct answer and E is not the correct answer. Now, these are certain other definitions related to this. So, early neonatal deaths or the death rates, they are the deaths at 0 to 6 days. That is the first 7 days of life. So, 0 to 6 days of life per 1,000 live births. Late neonatal deaths are between 7th to 27th day. But again, per 1,000 live births, neonatal is 0 to 27. That is the first 28 days. And then post neonatal deaths or death rates are those deaths or the number of deaths occurring after the 28 days, starting from 28 day till 1 year. That is the post neonatal deaths or the death rate. So this is how the various definitions are. And I think now it should be clear and you will not be forgetting it. Coming to next question. Now this is something slightly tricky, right? This is slightly tricky. So regarding the prevalence and incidence, which of the following is false? We are going to talk about prevalence and incidence. Which statement is false? Remember, we are looking for the statement which is not true. So prevalence is a measure of disease occurrence. Incidence is a measure of disease occurrence. Incidence is equal to prevalence into time. Prevalence is total number of cases detected at a particular point of time. And incidence is measure of new cases over a particular period of time. So which is the false statement that is not correct? This is slightly tricky. Let me see who is going to answer it correctly because that would be something. Oh my God, you got it. You are the statistics hero if you are answering this question appropriately. Yes, waiting for the answers. Is it A? Is it B? It is C or D or E? What it is? No answers. What happened? Try answering, no matter it goes wrong. We are going to discuss about the correct answer in a moment, but certainly would like to have your answers first. Do try. Okay, so we all know what is incidence and what is prevalence. Okay, C answer, B answer. Yes. Okay. Yes, Dr. Yashasvi Pandey, you got it right. Yes, you are a stats hero. So incidence is equal to prevalence into time is the correct answer. Now A and B, they both seem the same. A and B, they both seems to be the same. So why the one of these is not the correct false statement? So because basically either way we are measuring the disease occurring. Only thing is in prevalence we are measuring the disease at a particular time. While in an incidence we are measuring the disease occurring over the next few months, years or whatever time period we take. Now, if we look at C statement, incidence is equal to prevalence into time. So prevalence is there, but it's actually not the time we are looking at. We are looking at the duration. When we say that the months, years, we are looking at duration. We are not looking at the time, right? So time period or the duration would be the correct word here. The prevalence is the total number of cases detected at a particular point of time. This is absolutely correct. And incidence is a measure of new cases over a particular period of time. This is also correct, right? So C is the one which is not correct. Now let me make it simple. Let's simplify. I told you I'll be talking about the statistics in a storytelling pattern, right? So here is the story. Here is the first story to make your concept clear about the prevalence and incidence. So imagine a bucket catching rain. How much water is already in the bucket right now, right? Already the bucket has some kind of a water. So all the water collected so far, which was there and which is added, right? So that is all the water collected so far, old plus new. That is what the prevalence is. Incidence, how much new rain is falling into the bucket during the next 10 minutes. So we are looking at a time duration. In the next 10 minutes, how much water is coming in. So that's what is the incidence. So both are measuring the disease. That's why our A and B option was not wrong because both of them are measuring the disease occurrence. Only thing is the prevalence is measuring the disease occurrence both old and new, while the incidence is measuring the disease occurrence only only the new disease, right? So that's how the A and B statements were right. So memory tip, P for prevalence and P for present, right? Anything in the present time is prevalence. Incidence is incoming. It's coming new, right? Coming into. So EI incidence and it's coming. So incoming cases. So you can also remember as a prevalence is like a snapshot. How many people have the disease now? You take a picture. Incidence is like a video. You record over the time how many of it are there getting it. So that's the incidence and the prevalence. Now, why option C we said is false? Imagine you are filling a bathtub. The incidence is there, is coming in. Then, over a period of time, these cases will collect and they will become the prevalence, right? So, therefore, incidence, it should be multiplied by this should be multiplied by the time duration. That will actually make the exact figure here. So incidence is not equal to prevalence into time, right? So that's not the correct thing here. If the people stay sick longer, higher duration, prevalence increases. If the new cases go up, prevalence also increases. So it should be prevalence into time duration. That would make the correct answer here. I hope the concept about the incidence and the prevalence is now easy for you. How did you like the story? I would like to listen from you in the live chat because that will motivate me to bring you more stories and make your studies more efficient and easy and save your study time because with story you will be remembering it quickly and you won't be forgetting it so you don't have to revise it again and again. And of course, this is a summary. So that's what our motto is to make you study in 70% less study time with this kind of a system. How did you like it? Please let me know in the live chat. Okay. So before I move on to the next question, yes, thank you so much for the wonderful answers. And yes, good to know that you are benefited with that. Okay, so 25 pregnant women were sampled during the antenatal period to assess the number of episodes of urinary incontinence, right? 25 pregnant women were sampled during the antenatal period to assess the number of episodes of urinary incontinence. From a population of 3,500, the sample showed mean number of episodes per patient is 30, standard deviation is 10, and sample size is 20. What is the standard error of mean? Now, this is a simple calculation. Let's see who has the best maths, who can calculate it earliest. Yes, a quick, simple calculation. Simple calculation. How to calculate with this? Yes, that's the correct answer. That's the correct answer. So yes, two is the correct answer. Absolutely fine. Very good. Very good. That's the correct answer. So what is the formula which we have used here, right? We have used the formula of the standard error of mean. So standard error of mean is equal to standard deviation divided by the sample size. So now in this case, the population, the number of population given to you is a distractor. We don't need that at all, right? We just need standard deviation upon the sample size. So that's what we are using here. Standard deviation upon under root 25. So it becomes 10 by 5, 2. So it is population size is irrelevant. So don't let the 3500 population distract you. Don't put this in the sample size, okay? That's very important. That's the examiner's trap. For SEM, we only care about the sample size and the spread. Ignore the rest. So that's how this is. Very good. So who won this time? It is again Dr. Jayadishi Singh. She again got the best, the first, fastest finger first. So great, congratulations. Again, we now move on to SBA 4. The mean booking weight of an antenatal population of 125 women is 80 kg. With the standard error of mean of 5 kg, what is the 95% confidence interval for the mean booking weight? Oh, yes. So, waiting for the answers. Who is going to rock this question? Yes. So, what the mean booking weight of an antenatal population of 125 women is 80 kg. And the standard error of mean is 5 kg. So what is the 95% confidence interval for the mean booking weight? Oh, there is some mistake in the calculation. B, E, I've got the two options, but looking for more options till I go to the correct option. So B, E, what we have to do? Yes, Dr. Khushbu Tiwari. She came up with the right answer. Well done. Good. Clap for you, right? So 70 to 90 kg is the correct answer. How do we calculate, right? How do we calculate? So we do have here the 95% confidence interval for formula. So in that, when we round off the figure, it becomes 2. So 95% confidence interval, the formula we have applied is mean plus minus 2 into standard error of mean. Now from our question, we know that mean is 80 and 2 into standard error of mean is 5. So 80 plus minus 10. So 70 to 90 kg. So it is 70 to 90 kg. So 25% confidence interval, mean plus minus 2 into standard error of mean. 95% confidence interval, 80 plus minus 2 into 5. And that becomes 70 to 90 kg. I hope this is clear about this formula. There is no, just remember this basic formula and put in the values here. As you put the value, you get this answer. Right? Is it correct? Okay, so that's it. Good. Okay, great. Now coming to the next question. This is again seems to be a good lengthy question, but actually it is easy. So again, this question will clarify all your doubts about the null hypothesis and type 1 and type 2 errors. So this question will clarify all those doubts. Now, which of the following is correct for hypothesis testing? Null hypothesis specifies a hypothesized real value for a parameter. Type 1 error occurs when the null hypothesis is not rejected, when it is false. Type 2 error occurs when the null hypothesis is rejected, when it is true. The power of the test is the probability of accepting the null hypothesis when it is false. An alternative hypothesis specifies the real value for a parameter, which will be considered when the null hypothesis is not rejected. So this is which of the following is correct for hypothesis testing. So which do you think is the correct one? So the answer which is coming up here is C, right? Okay. Till now, I have got all the answers as C. C says type 2 error occurs when the null hypothesis is rejected when it is true. Everybody waiting for more answers. We should have more answers. That would be the better one. Yes, good to see all your participation. Yes. Okay. So let's look at the first point. Null hypothesis specifies a hypothesized real value for a parameter. So definitely, if it gives you a proper value, if it gives you a proper value like wow, how much significant this is, then it is basically when this is basically a number. So you usually give this a number, but then it is basically like you say that this much probability is there of getting this right. So that is a correct thing. Now type 1 error is. Type 1 error occurs when the null hypothesis is not rejected when it is false. So is this a correct statement? So what happens in the type 1 error? Type 1 errors are basically in this part. Yes, I have another answer here. A. I'm coming to which is correct, right? I'm just coming. Type 1 error is something which is we call as when you are actually saying you rejected the no difference idea, but you were wrong. So you actually rejected the null hypothesis, but you were wrong. So type 1 is not the correct statement here. Type 2 error occurs when the null hypothesis is rejected when it is true, right? So that is basically rejecting the true null hypothesis. So this is partly correct. The power of the test is the probability of accepting the null hypothesis when it is false. So power of the test is not the probability of accepting the null hypothesis when it is false. This is basically a wrong statement because that's not what the power is. What is the alternative hypothesis specifies a real value for the parameter which will be considered when the null hypothesis is not rejected. Now these are complicated statements. Let's first break it down and then we will come to the right answer so that everybody can understand this, right? Now I'm coming with a example of ice creams, right? Again, coming to my storytelling idea. There's a new flavor in the market, which is magic mango. The shopkeeper says, I don't think it tastes any different from the regular mango. That's your null hypothesis, that its taste is same as was any previous. There is no difference between the taste. Nothing new, no difference, no effect. That's the null hypothesis. But a curious foodie like me comes there, and I'd say that I think magic mango tastes better. So this is my alternative hypothesis, right? So alternative hypothesis is not a number, right? That's not a number. That's basically a hypothesis which I have created, which I believe is the correct one. I say that there is a difference. Mango is certainly more amazing, right? So what I do, I decide to take up a test. So you take a few bites, think deeply, and then make a decision. What could be the two decisions? What could be the probability of two possible decisions? If you are really sure it tastes bitter, then you will say that reject the null and say, yes, it's different. I reject the null hypothesis and I say, yes, it's different. Or I'm not confident or not unsure. And I just say, I don't reject the null, but I say maybe it's not that special. And I go with the shopkeeper. Now, but mistakes can always happen. I may be perceiving which is actually not right. So let's say you tell your friends, that's amazing. But actually, the shopkeeper was right, right? Shopkeeper was right that there was no difference in the idea there, no difference in the ice cream. And but I was saying, no, it's amazing. So I rejected the no difference idea, but I was wrong, right? So I rejected the no difference idea, but I was wrong. So I said it is positive, but actually it was false positive, right? So it was false positive. Now let's go back and look here. Type 1 error occurs when the null hypothesis is not rejected and when it is false, right? So this idea does not aligns with that, right? So this is not the correct statement here. Now, if you look at the alternative hypothesis, this specifies the real value. No, it does not specify any real value. It is just the hypothesis which is happening. Now, but mistake, then I come on to the next one, right? I said that there is nothing special, but actually I missed out on a true amazing flavor. So that's a type 2 error. I didn't reject the no difference, but again, you were wrong, right? So I accepted the null hypothesis, but I was wrong. So I was false negative. So in this is mentioning that the null hypothesis is rejected, but actually I was accepting the null hypothesis, which was actually not true. So again, C is also wrong here. So B is wrong, C is wrong. B is not false positive, C is not false negative. Now E is also not correct. So what is there? A is the correct answer because the A says that there is a number. So this is the final, the summary of everything. So null hypothesis sets a real value. That is, I say that it is sweetness is 8 out of 10. So yes, this is correct. It's a real value. Type 1 error, not rejecting false. You missed a great flavor. So that's actually not. So I said I missed a great flavor. So I am actually accepting the null hypothesis. So that becomes type 2. So type 2 error, actually what is given in the type 2 in the statement is actually type 1. And rest 2 are not correct. So basically the A statement is correct. So that's how the correct answer is A, and the winner is Dr. Beena Tandon. She has won this question, and that was a very, very tricky question, and an amazing answer given by her. Certainly deserves an applause. Very good. So I think now it should be very, very clear. Whenever you think about the null hypothesis, think about the type 1 error as the false positive and type 2 error as false negative. That's the way it is. Always remember the mango ice cream. You said that it's amazing, but it was not. So that was false positive, type 1 error. In the type 2, you said there is nothing special. You went with you accepted the null hypothesis, but actually it was not. So that becomes the false negative. So false positive and false negative. I hope this question is clear how it is. Would like to hear from you. Was this story clear or not? Or any confusions? If at all, let me know. I can repeat it for you as well. Okay, great, great. Thank you. Thank you. Coming on to the next, another important topic, the studies. See, I'm touching most of the topics of statistics. We talked about the incidence prevalence, we talked about the null hypothesis and the type 1 and type 2 errors, which are very important. Then we also solved one of the question. So now it is time to, which of the following studies is the most appropriate to assess the prognosis of a disease? So in this, basically, when we talk about the prognosis, which is the correct answer? Is it a randomized control study? Is it a case control study, cross-sectional analysis, cohort study, longitudinal study? Which is correct? For the prognosis, what we are doing, we are going ahead in time. Yes, very good. It's D. Dr. Khushbu Tiwari again. She won this question as well. Now, again, a story coming up for you to understand the cohort study. You are a doctor and you just diagnosed 100 patients with early stage breast cancer. Now, your patient asks, Doc, what's going to happen to me in next 5 years? Will I survive? Will it spread? What's the usual course? That's when you need to assess the prognosis. So this is what is. Now you will go over a period of time and tell about the prognosis. So this is cohort study is your answer. You follow a group of people who all start disease free or at the same stage and observe outcomes over time. For prognosis, you start with patients who already have the disease and follow them to see what happens, who improves, who worsens, and who does not survive. Time is the key ingredient here. So, this is the main thing, and so this is the cohort study. See, type of studies is a very important topic for both part 1 and part 2 exams. You should be able to define what type of a study design we are using here. Why others were wrong? So randomized control trial was wrong because it is good for treatment efficacy. We manipulate with the interventions. We are intervening. We are not just observing. Cohort is an observational study, right? We are observing the behavior. So that's the observation study. Case control study starts with the outcome, looks backwards, great for risk factors, but not prognosis. A cross-sectional study is a snapshot. You take a cut at a period. At a certain time, you just take a cut. Longitudinal is a broader study, a broader term in which we include all the studies where we go further in the time period. So cohort is one part of it, right? So cohort is more specific answer. To predict the future of disease, follow the ones living it. That's what a cohort study does. Okay. Now coming to the next question, yet another possibility of getting your name announced in the live session. So let's see who is the winner now. Study Y involves trial of 72 patients. It finds improved outcomes in the treatment group being treated with drug B than those taking place with B, with other drug. The null hypothesis that drug B makes no difference to outcomes is rejected. Several larger studies involving several thousand patients clearly demonstrate that drug B makes no statistical difference. What type of error has occurred? You are saying that the difference is there, but actually multiple studies are there which say that there is no difference. So what you are doing is you are creating a, yes, that's, I could see the correct answer. Yes, but I will certainly wait for more answers to come. So you are creating a false noise. This is going to work, while majority of the studies are saying it's not going to work. So you are creating a false alarm. I have the answer, it's going to work, but it's actually not working. Multiple studies have already shown that. So this is a type 1 error. False alarm, false positive, right? So again, the false positive. Imagine you have a fire alarm that goes off, but there is no fire. You just panicked over nothing. That's exactly what happens in study Y. They thought drug B worked, but it didn't. So this is a type 1 error and also called the false positive. You reject the null hypothesis even it was actually true. What's happening otherwise, type 2 is false negative, that the drug really had the effect, but you are saying that it's not having the effect. So missing a real effect is not the correct thing here. Selection bias, no, nothing there. P-value error, none of the above. That's it. So A is the correct answer. And who is the winner? Yes, we have a new winner today. Dr. Swati Jain. Yes, very good, very good. Awesome. I'm so much proud of my students. You all have learned it so brilliantly. Good, very good. Small studies may shout out Eureka, but sometimes it's just a false alarm. We should rely on the bigger analysis. And that's the type 1 error. Here, this is the next question. Another opportunity to be a winner this time. So if TP, true positive and false positive, what is represented by an equation TP upon TP plus false positive? What is represented by the equation TP upon TP plus false positive? TP upon TP plus false positive. Yes, that's correct. That's correct. So basically, TP is, this is basically your C answer, that is positive predictive value. Simple formulas. We have that ABCD table through which we can solve all these things. So positive predictive value is the very correct answer. How do you define positive predictive value? Think of as yourself in an airport passing through the metal detector. It beeps for 10 people. 7 had metal and 3 were false alarms. So 7 had the metal. So they were positive. They had the disease and they were detected, right? So this is the positive predictive value. So 7 upon total 10 people were alarmed. So that means 10 people were tested positive, but actually 7 had the disease. So 7 out of 10 becomes 70%. So your detector has a 70% positive predictive value. That's how trustworthy a positive result is. If you go back, there is a confusion between A and C. So let me clarify. Here you are checking the true positive, the people who have got the disease among those who all tested positive, right? How do you differentiate it from the sensitivity? The denominator in the sensitivity is the total population, not the positives only, right? So TP plus divided by the total positives becomes the positive predictive value. Means, as I said, how many patients got alarmed, right? So they were 10, right? So they were like they are carrying the metal. They were detected as positive. But actually out of those, only 7 really had the metal. So this is the positive predictive value and C is the correct answer. And happy to announce that yet another time Dr. Jadishi Singh has again got the first fastest finger first prize again. So because she is the third time she has got, in the third question she has got this prize. So I think she deserves a round of applause for her. Okay, coming to the next question. You want to investigate the duration of cesarean section in 2 groups of women, one with preeclampsia and one without. Now, this is about the statistical test. Yet another important topic. I've taken the questions from different topics so that I can give you the overview of what you need to know when you go to exam with statistics, right? So you want to investigate the duration of cesarean section in 2 groups of women, one with preeclampsia and one without. The duration is recorded for each woman, but the data cannot be assumed to be normally distributed. Which non-parametric statistical test is most appropriate to compare the 2 groups? Right? So which non-parametric statistical test is most appropriate to compare the 2 groups? So that's the, yes, chi-square, students t-test, Mann-Whitney. So basically what we are too. So it is not a normally distributed data, and two different categories where we are assessing the mean. So we are assessing the mean and taking out the difference. So it is, yes, it's the C. Man witness you test is the correct answer. That's the correct answer. So again, Dr. Beena Tandon, she was the first one to answer it correctly. That's again, she's also got this prize second time. So clapping. Imagine you are comparing surgery times for women undergoing C-sections, some with preeclampsia and some without. You collect all the times, but you notice that the data is not normally distributed. Maybe there is long delay, some quick operations. So when we are comparing two independent groups with non-parametric data, use the Mann-Whitney U test. So that's it. For the Mann-Whitney U test, if it is a parametric data, now, this is another opportunity to score as a winner. If it is a parametric data and you are looking at two independent group means, then what? Then what? If it is parametric data and it is you are calculating the mean in two independent groups, then what? Then it is unpaired, yes, unpaired what? Complete it. Unpaired, yes, yes, yes. Come over it completely. Yes, Dr. Rashim, correct. Unpaired T test. Unpaired T test. Yes, Dr. Rashim Aneja. She got the winner this time. Okay, yes, that's absolutely correct. So two independent groups, not normally distributed data, so no T test. And so non-parametric is man-weight T test. That's the correct answer. And now this is the last question. Oh my God, it has the answer on it. But I would be happy to see the calculation, right? So here, using the data in the table below, what is the likelihood ratio for an ultrasound Doppler test for deep vein thrombosis? You have to calculate the likelihood ratio. Yes, try calculating it. Likelihood ratio. What is the formula? Let me tell you. I think this is a bit of a calculation here, but this is important, right? This question is about how powerful a positive Doppler ultrasound in diagnosing DVT. So what is the formula? We have to calculate first the sensitivity and the specificity. And then likelihood ratio is sensitivity divided by 1 minus specificity. So first we calculated the sensitivity, then we calculate uh, the specificity and then put them in these values, and that's why how the answer is here. So basically, first we need to know the formula for sensitivity, then yes, and then it will be the specificity formula. And once you know that, yes, the answer, I can see the formulas in the live chat as well. So what is the formula for sensitivity is true positive upon true positive plus false negative, right? So let's see, we have taken these true positive upon true positive plus false negative. So that's what we have done here. So this is this specificity. Also, we have calculated like that. Then sensitivity 1 minus specificity, and it comes out to be the 18. And Dr. Malika Pala, she's the first one to put all the calculation in the chat box. So the final question winner is Dr. Malika. So that's the correct answer here. And I think you all have done it brilliantly, and many of my students were here. Some of the new students were also there. But I'm proud of my students. You all have done so perfectly fine, and you are very well prepared for your exam. So hope to see you all shining in the next part 2 course. So basically, the new part 1 and the part 2 batches for the January 2026 are starting from July. And As you know, those who have already joined us, they know that how we help you study in less study time. Those who are new, you should know us. You know that how the concepts become easy with us, how you save time. So what you get is no fluff video lectures, very easy. Live sessions with lot of recall drills, tricky questions. Final mocks are there, Telegram group discussions are there, summaries are provided, and unlimited access till you pass. So that's not something any course. So two unique features of us: 70% less study time and unlimited access with which we help our students. So both of you, if you are part one going for January 2026, you are welcome. If you are going for part one July, then I wish you all the best that you pass. And we have a pre-result booking offer. If you book your part two course before getting your part two results, there is a special offer for that. So see you there in that offer. And these are the real results, real fast. I got 76% just following your course, Dr. Chavi. This is for part two. For part two, it's huge. For part one, we have 90% and above marks. I was totally lost. Your videos brought me back on track. This is one of the students who was just fed up of giving the exam repeatedly, not want to look at the guidelines, but then she loved the videos. Students have prepared in 3 months, 2 months, and just yet able to pass the exam. So join in July and you will get early access to our exclusive bonuses. And as I said, for part two, those who are appearing for part one, they can join part two with pre-result booking offer. These are our numbers. This is our website or email. Do just log in the official media only. Don't go for any admissions, fraud admissions on the Telegram. There's a lot of fraud going on. So just connect with us on the WhatsApp or directly go to our website and look at the courses, take the free trials, and our email ID is there if you want any more information. This is one-to-one guidance. You can book a call with me and we can discuss one-to-one your strategy. Thank you so much being here. Yeah, thank you, Dr. Swati. It's really fun to study under your able guidance. Dr. Veena says interesting way. Dr. Khushbu, very good videos, ma'am. Thank you so much. Thank you so much. The love you all give to me is the motivation and is the inspiration which makes me better every day. And I hope I keep having more number of students. And I just wish everybody can just achieve MRCOG in 1 year. 365 days, you get your dream degree in 70% less study time where you can actually work, go to work, be with the family, and enjoy everything and still get your dream degree. How does that sound? Thank you so much and see you again in the next session. Bye bye. Take care. Bye.